Good morning, ladies and gentlemen, on this wonderful Wednesday morning. I believe it is April the 8th. Wow, time is flying fast when you're in quarantine. But to get on with today's lesson, today we are going to be talking about quadratics. Specifically, quadratics are the equations where you see something like x squared. And when it says parabola, I mean we are going to be graphing, and it's going to be fun. As you can tell, I've got a little graphing thing right there. Let me see if I can move my camera so we can see kind of more of the graph. But we'll make do as we can. But starting off everything, I want you guys to understand that the quadratic functions graph is what we call a distinct parabola. As we graph it, it is either going to look like a U or a funky n, and all quadratics take that form. There isn't going to be a quadratic that I know of that doesn't take those forms when you graph them. And let's see this in action. Now, admittedly, not everyone might have a graphing calculator or a calculator that can do these graphs. Luckily, I have kind of planned a backup. One thing I do recommend if it comes to graphing is there's this lovely website called Desmus. You can see in the top right here that you can do all sorts of graphing if you need to, but I'll bring that up when I need it. But if I want to graph these, main things that I need to understand is where's the graph going and what are some distinct parts. I should always know that every quadratic is in the form of y is equal to ax squared, and my kid should already know this, plus a bx plus c. And a and b are the coefficients that come in front of your variables, and c is your y-intercept. Now for this one, for this first one, y is equal to x squared minus 4x plus 6. It has a y-intercept of a positive 6. Now, as you can see on this graph, nothing is labeled, which is an important thing. As you guys are making graphs, if your graph is understandable, then it's on point. Then that's fine. Not everything has to be meticulously or painstakingly drawn out. Like, I'm going to say 6 is right about here. 6 is right about there. Well, now I should also determine what my middle point is, or at least what my, not my middle point, my vertex. Every vertex is going to be in the form of negative b divided by 2a. Now what's b in this case? Negative 4. Now what's a negative of a negative? A positive. A in this case, we don't see a number here, but the number in front of this would be understood as a 1. I am going to change that real quick. Now if we do this for the second one, ladies and gentlemen, you should see that it's kind of the same thing here. Instead of a negative x squared, it's going to be a negative 1x squared. And that's going to have a negative 6 as an intercept, but we'll talk about that when we get to it. There we go. So, 2 times 1 is 2, so I'm going to have a vertex at x is equal to 2. Alright, so if that's 6, that means that would have to be 6 as well, so that would have to be 3, so I'm going to say 2 is right about there. 2 is right about there. And if I plug in 2 for this, I can find my y value. What's 2 squared? 4. What's negative 4 times 2? Negative 8. So I've got 4 minus 8 plus 6. I really apologize, I'm getting a little jumbled here. But this is finding, we have our x value, I'm trying to find our y value for our vertex. 4 minus 8 gives me a minus 4, plus 2 gives me a positive 2. So if that's about 2, that's about 2. There we go. I'm going to move this over there. We already know it's a quadratic parabola. So Now, once again, I apologize. This graph isn't going to be very pretty, but that's what our graph looks like. Now, boys and girls, if you say at this bottom one, like, hey, everything's the same as the first one, for number 2, everything's the same as number 1, just all your signs are flipped. Well, that's a pretty good indicator, which means everything else would be roughly flipped as well. And let me put this in red. And there we go. This is for my number 2. Because this, if that's a positive 6, that would be a negative 6. The same thing applies. Your negative b divided by 2a, well, that would be a negative 4 divided by negative 2, which would still give you 2 as your x value for your vertex, meaning your highest or your lowest point. Well, you plug that into here, you're pretty much going to get the same thing, just a negative. It would just be 2 minus 6, or it would give you 4 minus 6, which would give you a negative 2. Now, once again, if you don't have a graphing calculator and you don't think I'm telling the truth, some kids don't, I would fully recommend going to this website called desmus.com. Pop on over there, desmus.com. Let me move my screen. Oh, geez. I'm just trying to... This thing apparently does not want to be moved. But, as we see... Oh, hey, here's my 2 equations. There's my first one. Looks pretty good to me. You can check that right there. Oh, what's that? That's an intercept of 0 and 2. What's that? Oh, it's a vertex of 2 and 2. And if we get my negative one, oh, it looks like the same thing. It just looks like it's flipped upside down. So, hey, awesome, we did a good job. Let me blank those 2 out, but remember, again, it says desmus.com. It's a good online calculator tool. You can also do tables on it. I might spend Friday just going over what we could do on this. But let's get back to the lesson. All right. I want us to be able to make these graphs. Can you make this graph just based on what we did just previously? If you have access to desmus.com, yes, you can. You can definitely make these graphs. But let's see what we can do. Let's try to figure out, our intercepts are obviously a positive 5 and a negative 1, right? So let me just throw that on there. I want to use the same thing. If that was a 6, I want to say a 5 is right there. 5. Please pay no attention to the apostrophe. And if that's a 6, that's a 3. That would be a negative 1. Awesome, I got my y-intercepts. Now let's figure out what our x values for our vertex are. Remember, we have to use b, this term, divided by 2a, which is that term. So this is going to be negative of a negative, which is a positive. Minerva girl. That's my cat over there. She's messing with something underneath one of the cabinets. Divided by 2a, which would be 2 times 1, which would be 2. My x value for this is going to be 4. So I've got a value of 4 right about there. And this one, it's going to be similar. Negative of a negative is a positive, so that is a positive 4 divided by 2a, 2, which gives me 2. And if that's a 4, that gives me a 2. Now if you plug in your values, if you plug in 4 into this, that's going to be 4 squared minus 32 plus 5. Well, 4 times 4 is 16, so let me just write a 16. 16 minus 32 is a negative 16 plus 5 is a negative 11. Well, if that's a 6, that's going to be 9, that's going to be 12, negative 11 is going to be right about here. And once again, please forgive me as I show my ineptitude and my drawing skills. These hands were meant to take notes, not to graph. In fact, I think I am going to try to erase that. That was quite pitiful. But you kind of see what I'm going for right here, hopefully. There we go, that's at least a better start. Not as ugly, but still pretty ugly. Alright, same thing here. Throw in your 2 into these, you get 4 minus 8 minus 1, or just 4 minus 9, gives you a negative 5. Luckily, since we know what a positive 5 is, a negative 5 should be right about here. And it looks like these two lines intersect in color red. It would look about that. And you can double check this, go into Desmos, get rid of these. There's my first one. Oh look, that looks very correct. And that one, it also looks correct. So ladies and gentlemen, if you are keeping up, good job. Let's move on to a better topic. So, if I can move my camera out of the way, want to be able to figure out when are these two quadratic functions going to intersect? Meaning, is there a specific x value where you have, that was meant to be a question mark, is there a specific x value, because remember when we're looking for intersections you want to find x values, is there a specific x value where the y values, y1, y2, are going to be the same? Now boys and girls, ladies and gentlemen, parents of all ages, if there is an intersection, you can show it by setting the two equations equal to each other. So I have an x squared plus 4x plus 3 is equal to x squared minus 4x minus 1. Now, ladies and gentlemen, if you want to figure out when these are two going to intersect, you need to boil down to where you have just x by itself at the end. In order to do that, you have to do some opposite operations. Let's see if we can get rid of some things. I want to move this x squared over to the other side. What's the opposite of a plus x squared? A minus x squared, right? So switching colors, minus x squared on both sides, minus x squared on both sides. Well, x squared minus x squared gets rid of x squared, leaving you with 4x minus 3 is equal to a negative 4x minus 1. Now, Mr. K, you've got a 4x and a 4x. Is the same thing going to happen? No. You might think the same thing's going to happen, but these aren't technically the same thing. That's a positive 4x, that's a minus 4x. So what's the opposite of a minus 4x? A plus 4x. And what's a 4x plus 4x? Well, what's 4 plus 4? 8. Good job, team, you can do math. That is an 8x minus 3 is equal to negative 1. Well, do the next thing. What's the opposite of a minus 3? Positive 3. So, moving my stuff over there. Hello, Minerva. You're a cute little kitty. Well, what's negative 1 plus 3? 2. And what's 2 divided by 8? X is equal to 1/4. Or, I think she was chewing on plastic. I apologize, I had to jump. Make sure my cat wasn't doing something dumb. She'll eat anything. Alright, so that is the solution to my equation. Now, we are running short on time, so I'm going to kind of breeze through the last one. Definitely rewind the video if you want to try to figure out how, if you need to back up and learn anything. On my next one, I want you to take the time, figure out the solution to where these two intersect. Now, if you work it out, pause the video, work it out on your own, x is going to be equal to 2. If you plug in 2 to both of these, you get the same value. If you graph these equations, this is what they're going to look like. That's my first one, x squared plus 2x minus 8. And that's my bottom one, x squared minus 3x plus 2. And what's this? Oh, they intersected too. It's as if, you know, I knew what I was doing. Anyways, ladies and gentlemen, hope you have yourselves a good Wednesday. Stay safe, stay inside, do what you can. Make sure to check out my website, and make sure you're trying to go to Microsoft Teams. Because some assignments are going to start rolling out there. And yeah, I'm definitely starting to put some assignments up there, so you need to make sure to get them done. Have a nice day.